This is one of my very favorite examples from this section. We're going to find the power series for arctan of x. Now, arctan of x doesn't have the right form for us to be able to pull the power series out in the same way that we've been doing, but the derivative does. The derivative of arctan x is 1 over 1 plus x squared, and we're going to rewrite that as 1 over 1 minus negative x squared. That way we've got a is 1 and r is minus x squared. So if we start writing this out as a series, 1 over 1 plus x squared is 1, and then minus x squared plus x to the 4th minus x to the 6th plus x to the 8th minus x to the 10 plus etc. I'm not going to worry about putting this into sigma notation because we need to do we need to integrate this. Reason being, the series we're after is arctan, and the series we have so far is the derivative of arctan. So what we need to do is integrate both sides of this thing. I'm going to integrate this with respect to x. And same thing over here. Integrate this with respect to x. This side we know gives us arctan. This side over here gives us, well, we'll see in a second. Don't forget about your constant of integration. I'm going to put the plus c on the front. Then I'm going to integrate this stuff term by term. Integrate 1, that gives us x. This gives us minus 1/3 x cubed. The x to the 4th integrates to give us plus 1/5 x to the 5, minus 1/7 x to the 7th, plus 1/9 x to the 9th, etc. Now, before we do anything else, let's find what this c is. We can do that by plugging in 0. If I plug 0 into both sides of this, we get a 0 here and a 0 for all these. Arctan of 0 over here is just 0. And on the other side, all these things are just c plus a bunch of zeros. So we get c is 0. So I'm going to go back and erase all these little zeros, just because they're cluttering things up. And so now we can write this. Okay, we've got to come up with a formula for the terms here. Now each term has 3 things going on. It's got a sign, it's got a coefficient, and it's got an exponent. So let's label this above with our n values. I'm going to start with 0. The key here is to realize that the numbers involved here for the exponents and the denominators, they're all 2 times n plus 1. That works here because you get 2 times 1 plus 1 is 3, 2 times 2 plus 1 is 5, 2 times 3 plus 1 is 7, and so on. So the formula we get is arctan is, let's see, we get negative 1 raised to the n power. And you get x to the 2n plus 1. All that over 2n plus 1. And this is our power series for arctan. Now the interval of convergence, I'm not going to work that out. I worked it out earlier. The interval of convergence for this thing is everything from negative 1 to 1. So let's look at Desmos and see that this series, when we plot it, actually gives us the same function as arctan when we look between negative 1 and 1. Okay, we got arctan graphed here. Now let's graph the sum that we just found. It's the sum, n goes from 0 to something big, of up top we've got -1 to the n, and then we've got x raised to the 2n plus 1. We're going to put all of that over 2n plus 1. And I'll get my slider. Let's go from 0 to, say, 20, 29. That's good, too. And let's look at this. So we start with L equals 0. We get this. And when L grows larger, we get a polynomial that gets closer and closer, an approximation to this. But notice the approximation is only good from -1 to 1. After there, it diverges from it. But we get something that's the larger L is, the better the approximation is. If we zoom way in here, we can see from -1 up to here, the approximation starts to get a little bit poor. If I change this from 229 to 290, notice these larger values, it just gets closer and closer. So this is the power series for Arctan. Desmos seems to have stalled a little bit. But an interesting thing here is this is just a polynomial. If we stop it at right here, if I stop it at L equals 10, we zoom out, what this is up here, it's really just a polynomial with 10 terms, or I guess it has 11 terms because it's got one for n equals 0. It would have 11 terms, and its degree would be 21. But it's a really good approximation. If you were stranded on a desert island and you had to compute arctan of something, you could do it this way, although you'd probably have other concerns if that were the case. Anyway, that's the Arctan example.